Welcome to part 7 of lecture 3 series that is focused on scripted pipeline, declarative versus scripted, review of syntax and environmental variables, parameters, input steps, post actions, and complete pipeline and best practices. So this is the final section of the lecture and it ties everything together that we have learned so far. Let's review the important concept within it, that is the environmental variable. So let's understand first what the environment variables is. It is simply a key value pair. Think of it as a variable that Jenkins makes available during pipeline execution. For example, that path. So here the key is Java home and its value is the location where Java is installed. So these variables are available throughout the pipeline and can be accessed whenever required. Environment variables are useful for several reasons. First, they allow us to store the configuration values instead of hard-coding them inside the pipeline. Instead of writing the application name or server URL multiple times, we store it once as an environmental variable. Another important use is storing sensitive information. Rather than placing passwords directly inside the Jenkins file, Jenkins retrieves them securely using credentials and exposes them during execution. Environmental variables also configure the build environment. For example, the Java installation path, the Maven home directory, or the location where the build artifacts should be stored. Finally, because these variables are available throughout the pipeline, multiple stages can reuse the same values without duplication. Now let's move to another important concept, that is build parameters. So Jenkins allows us to create parameterized builds. This means that instead of hard coding values inside the pipeline, Jenkins asks the user to provide the values before the build starts. When we enable this project is parameterized and click add parameter, Jenkins displays several parameter types. Each one is designed for a different kind of input. Parameters allow users to provide input before the pipeline starts. Let's understand each of them one by one. So string parameter is the simplest parameter type. It accepts a single line of text entered by the user. For example, instead of hard coding the git branch inside the pipeline, we can ask the user which branch should be built. The user might enter main, develop, or a feature login. So this makes the pipeline reusable because the same pipeline can build different branches without any code modification. Then choice parameter presents the user with a drop-down list. Instead of typing a value, user selects one of the predefined options. For example, before deployment, Jenkins may ask whether the application should be deployed to development, testing, or production. Since the values are predefined, this reduces the typing mistakes and ensures only valid options are selected. A Boolean parameter is simply a checkbox. If the checkbox is selected, its value becomes true. If it is not selected, its value becomes false. Boolean parameters are commonly used when certain stages are optional. For example, before starting the pipeline, the Jenkins may ask, should the security scan be executed? If the checkbox is selected, the pipeline performs the scan, otherwise it skips that stage. A password parameter allows the users to enter sensitive information such as passwords. Unlike a string parameter, characters typed by the users are hidden using asterisks and dots. So this prevents the password from being visible on the screen while it is being entered. However, for long-term credentials, Jenkins recommends using the credentials parameter, which is even more secure. So credentials parameter is one of the most important types used in real projects. Instead of asking the user to type the password every time, Jenkins allows credentials to be stored securely in its credentials store. When the pipeline starts, the user simply selects one of the stored credentials. So these credentials may include a username and password, an SSH private key, an API token, or a secret text. So this approach is much safer because passwords are never exposed inside the Jenkins file. A file parameter allows the users to upload a file before the build starts. The uploaded file becomes available to the pipeline during the execution. For example, a deployment configuration, a SQL script, a certificate, or even a zip package can be uploaded. So pipeline can then use that file during execution. A multi-line string parameter is similar to a string parameter, except that it allows multiple lines of text. This is useful when the input is longer. For example, release notes, deployment comments, change descriptions, or large configuration values. A run parameter allows the user to select a previously completed Jenkins build. This is useful where another job depends on artifacts generated by an earlier build. For example, instead of building the application again, we may simply choose build number 25 and deploy the artifacts produced by that build. This saves both time and computing resources. Each parameter type serves a specific purpose. If we need a simple text, we will use a string parameter. If users should choose from the predefined values, we choose the choice parameter. For yes or no decisions, we use Boolean parameter. Sensitive values entered manually then we use a password parameter. And reusable secrets stored securely in Jenkins, then we use credentials parameter. When the pipeline required an uploaded file, we use file parameter. Long descriptions are handled with a multi-string parameter, and when we need a reference to an earlier Jenkins build, we use a run parameter. So by choosing the appropriate parameter type, we make our pipeline more flexible, interactive, secure, and easier for users to operate without modifying the Jenkins file itself. So instead of creating parameters through Jenkins interface, we can also define them directly inside the Jenkins file. Here the first parameter is the string parameter, second is the choice parameter, third is a Boolean parameter, and finally the text parameter creates a multi-line input box. Again, this is another advantage of pipeline as a code. The pipeline configuration is stored inside Jenkins file rather than being manually configured in Jenkins. Build parameters are entered before the pipeline starts. The input step is different. It allows Jenkins to pause the pipeline while it is running and wait for user interaction. So far, we have seen build parameters where Jenkins asks the user for information before the pipeline begins. The input step is different. Instead of asking before execution, Jenkins pauses the pipeline while it is running and waits for the user to respond. Think about a real software deployment. The application has already been built, testing has completed successfully, and the application has been deployed to the staging environment. Now comes an important question: should we deploy this application to production? So this decision actually requires approval from a release manager or a project lead. Instead of automatically continuing, the Jenkins pauses the pipeline and displays an input dialog. Only after user approves does Jenkins continue executing the remaining stages. This is exactly what the input step is designed for. Now let's see the example. Pipeline starts the declarative pipeline. Then agent any means pipeline can execute on any available Jenkins agent. So then next stage 1. So this stage deploys the application to the staging server. Here we are simply printing a message to simulate a successful deployment. So this stage is responsible for obtaining user approval. So input deploy to production. So this is the most important statement. When Jenkins reaches this line, it automatically pauses execution. Instead of moving to the next stage, Jenkins displays a dialog box with deploy to production text. So the pipeline remains paused until the authorized user clicks proceed. If the user clicks abort, the pipeline stops immediately, and this allows the organizations to include the manual approval before critical operations such as production deployment. Next, deploy to production. So if a user approves, Jenkins resumes the execution from exactly where it paused. Now the production deployment begins. This simply prints a deployment message, and in a real project this stage would execute deployment scripts. The input step is not limited to approvals, it can also collect information from the user. So in this example, Jenkins pauses the pipeline and the dialog box appears asking the user to enter a username. Let's understand each statement. So the script blocks allows us to write groovy code. The variable username stores whatever the user types. The input step creates the dialog box. The message property displays the prompt at the top of the dialog. The parameters section defines the input fields that will appear. Here we create a string parameter called username. Default value specifically specifies the initial values shown in the text box. Description provides additional guidance to the user. Once the user clicks proceed, the entered value is returned to the is returned by the input step and stored in the username variable. Finally, echo statement prints the entered username to the Jenkins console. The key difference is the timing. Build parameters are collected before Jenkins starts executing the pipeline. Input step is used during the execution, and build parameters are collected before Jenkins starts executing the pipeline. So key difference is the timing. Whenever human approval or additional information is required at a particular stage, especially before deployment to production, the input step provides a safe and interactive way to pause the pipeline and wait for user action. This makes Jenkins pipeline suitable for not only for fully automated CI/CD workflows, but also for controlled release processes where human intervention is required. So far we have been writing declarative pipeline. Now let's introduce another way of writing Jenkins pipeline, that is scripted pipeline. Students often ask, if declarative pipelines already work perfectly, then why do we need scripted pipeline? That's an excellent question. So the answer is flexibility. Think about driving a car. Most people drive an automatic transmission because it is easier. However, racing drivers can often prefer manual transmission because it provides a greater control. The same idea applies here. Declarative pipelines are easier to learn and they enforce a structured format, and they are perfect for beginners and for most software projects. Scripted pipelines, however, provide much greater programming flexibility. Instead of following a fixed structure, you can write complex logic using Groovy programming language. Suppose a food delivery application needs different deployment procedures depending on country. So if the deployment target is Pakistan, perform one operation. If it is Saudi Arabia, execute another. If it is UAE, deploy to a different cloud region. So writing this kind of complex decision making becomes much easier in scripted pipelines. Notice that scripted pipelines begin with the keyword node. Earlier, declarative pipelines use agent any, so both serve the similar purposes. They specify where the pipeline should execute. Inside the node block, we create stages exactly as before. So the difference is that scripted pipelines behave much more like a traditional programming. We write loops, conditions, functions, variables, exception handling, even reusable methods. Because scripted pipelines offer complete programming freedom, they are commonly used for highly customized enterprise workflows. However, that flexibility also makes them more difficult to read and maintain. That's why many organizations prefer declarative pipeline unless advanced logic is absolutely necessary. Now that we know Jenkins file can be written using either declarative or scripted syntax, let's compare them carefully. After both approaches achieve the same goal, that is automating a CI/CD pipeline, they are designed with different priorities. Let's begin with the first difference. The declarative pipeline is much easier to read. Its syntax is highly structured. Every pipeline follows the same overall layout with sections such as pipeline, agent, stages, stage, and steps. Because of this consistent structure, even someone who has never worked on that project before can quickly understand the workflow. They can immediately identify where the build starts, where testing happens, and where the deployment occurs. On the other hand, scripted pipeline resembles writing a normal program in Groovy. Developers have a much greater freedom to write conditions, loops, and functions and complex logic. While this flexibility is powerful, it also means the code can become longer and much more to understand. So someone unfamiliar with project may need significant time to follow the pipeline's execution flow. Now let's look at the second difference. So declarative pipeline includes a built-in validation. Before execution begins, Jenkins checks whether the pipeline follows a correct declarative syntax. If required sections are missing or placed incorrectly, Jenkins reports the configuration errors immediately. So this early validation helps the developers to detect the mistakes before the pipeline even starts. Scripted pipeline, however, offer much more programming freedom because the developers can write almost any Groovy logic. Jenkins cannot validate every possible scenario in advance. As a result, logical errors may only become visible during execution. Third difference is standardization. Imagine an organization where 20 developers are creating Jenkins pipelines. If everyone uses declarative syntax, every pipeline follows the same structure. So this consistency makes the pipelines easier to review, maintain, and troubleshoot. But in contrast, scripted pipelines allow each developer to organize the code differently. While this flexibility is useful for advanced workflow, it can also reduce consistency across the projects. So does it mean scripted pipelines are bad? Not at all. They simply solve a different type of problem. Let's see when each approach should be used. So which pipeline should we use? The answer depends on the complexity of automation. If your project follows a typical software delivery process, such as building the application, running automated tests, packaging the software, and deploying it, then you should use the declarative pipeline. This is exactly the type of workflow used by most organizations. Declarative pipeline provide all the necessary features while keeping the code simple and readable. However, some organizations have some much more complex automation requirements. For example, the pipeline may need to generate stages dynamically based on the configuration files, or execute the complicated conditional logic, or create reusable functions, or build custom workflows using maybe loops and advanced Groovy programming. So in such situations, a scripted pipeline becomes more suitable because it provides the flexibility needed for these advanced scenarios. So here's an easy rule to remember. If your workflow is a standard build, test, deploy pipeline, choose declarative. If your automation behaves more like a custom software application with complex programming logic, then consider the scripted pipeline. In modern software development, most organizations begin with declarative pipelines because they provide an excellent balance between simplicity, maintainability, and functionality. As your automation becomes more sophisticated, you can gradually introduce scripted pipeline features where they are genuinely needed. So far, we have learned how scripted pipelines are structured and how to write different pipeline stages, but in real DevOps projects, hard coding values inside the pipeline is never a good idea. Imagine writing a branch name, application version, deployment server, or credentials directly in your Jenkins file. Every time something changes, you have to edit the pipeline code, which increases the maintenance effort and introduces unnecessary risks. So this is exactly why environment variables exist. So environment variables allows us to store values separately from the pipeline logic. Instead of hard coding information, we reference the variables that Jenkins automatically provides, or variables that we define ourselves. These variables can be reused across multiple stages, making pipelines cleaner, easier to maintain, and much more flexible. So we'll learn how environmental variables work in scripted pipelines, how Jenkins provide built-in variables, and how we create our own variables and how to access them throughout the pipeline. Let's first understand what an environment variable actually is. Environment variable is simply a named storage location that holds some value. Instead of writing values directly into the code, we assign them to variables. For example, suppose your application version is 1.0 today. Instead of writing 1 in multiple places throughout the pipeline, you store it in a variable called version. Whenever the version changes to 2, you only update the variable once. So every state that references the version automatically starts using the new value. This makes pipelines significantly easier to manage, especially when they grow to hundreds of lines. Now let's see, why do we need environment variables? Environment variables are important. So first reason is maintainability. Instead of searching through dozens of pipeline steps to update a value, we update it in one place. Second benefit is consistency. If multiple stages need the same server name or version number, using a single variable ensures every stage uses exactly the same value. Third advantage is readability. Finally, variables make pipelines reusable across different environments such as deployment, testing, or production. One of the best features of Jenkins is that it automatically provides many environment variables for us. So these variables already contain useful information about the current build. For example, build number stores the current build number. Job name contains the name of the Jenkins project. Build URL provides the web address of the running build. Workspace points to the directory where the Jenkins checks out the source code. Assessing environmental variables inside a scripted pipeline is very simple. All environmental variables are available through the env object. Notice that every variable begins with an env dot. For example, env dot build number returns a current build number. Similarly, env dot job name returns the name of the Jenkins job. So this env object acts like a container that holds all the available environment variables. Whenever you need one of these values, you simply access it using env followed by a variable name. Let's see what happens when the pipeline executes. So Jenkins automatically substitutes each variable with its actual value. Instead of displaying env build number, the console shows the real build number. Similarly, job name becomes the actual project name. Workspace becomes the real directory path. This automatic substitution is what makes environmental variables so powerful. Now let's see creating custom environment variables. So besides Jenkins built-in variables, we can also create our own. Here we have created two custom variables. The first stores the application name, the second stores the application version. Notice that we still use the env object by assigning values to env.appName and env.version. So these variables become available throughout the pipeline. So this allows us to centralize the configuration information instead of repeating values multiple times. Updating variables, unlike constants, environment variables can also be updated during the pipeline execution. Initially, version contains 1.0. Later, we assigned it a new value of 2. Next time we print the variable, Jenkins displayed the updated value. So this becomes useful when one stage generates information such as version number, artifact name, or Docker image tag that later stages need to use. To conclude, here are a few best practices when working with environment variables. Always choose meaningful variable names that describe their purpose. Avoid hard-coding values directly inside your pipeline wherever possible. Reuse variables instead of repeating the same information throughout different stages. Separate configuration from business logic so changes become easier to manage. Finally, remember that Jenkins already provides many useful built-in variables, so take advantage of them before creating your own. Following these practices results in a cleaner, more maintainable, and production-ready Jenkins pipeline. Now let's end it with a small activity or a quiz. Which statement about environment variables and parameters is correct? The correct answer is C. At first glance, both the parameter and environment variables seem similar because they store values that are used by the pipeline. However, they serve the different purposes. Let's evaluate each option. So option A, that is both are always supplied by the user before the build starts. So is this correct? No. Only parameters are supplied by the user before the build begins. For example, user may enter the branch name or select the deployment environment. Environment variables, however, are usually predefined. They can be defined inside the Jenkins file provided by Jenkins itself or injected through credentials or plugins. Therefore, option A is incorrect. Then option B, environment variables are only available inside one stage. So this is also incorrect. One of the main advantages of environment variable is that they can be shared across multiple stages. For example, if we define app name as student portal, so we can access the app name in the build stage, in the test stage, in the package stage, or other stage also. So environmental variables are not limited to a single stage, so this option is also incorrect. Then option C, parameters are entered before execution, while environment variables can be predefined and accessed throughout the pipeline. So this statement perfectly describes the difference. Parameters allows the user to provide the values before the pipeline starts, and an environment variable already exists when the pipeline executes and remain available throughout the pipeline. So therefore option C is the correct option. And finally option D, that is environment variables and parameters are identical. So this is false. We already reviewed the differences in the previous options and solution discussion. Next, which keyword only exists in declarative pipeline? The correct option is C. So scripted pipeline do not use the pipeline keyword. They usually begin with the node keyword. Jenkins Pipelines contains build, test, package, and deploy. So tomorrow a security scan stage needs to be added. So which approach requires the least maintenance effort? Correct answer is B. Modify the existing Jenkins file and insert another stage. So this is exactly how pipelines are designed to work. We simply open the Jenkins file and add another stage block, for example stage named security scan, and add the relevant steps. Then save the file and commit this file to Git if necessary, and Jenkins then automatically includes this stage during the next build. So no additional jobs and plugins and complex reconfigurations. So that brings us to the end of this lecture series. Stay tuned for next lectures.